Okay, so now we've gone over some of the basic speed and velocity concepts, being able to go ahead and calculate them. Now we're going to go ahead and move on to the graphing portion. And as we've talked about before, many of the ACT tests require that you can efficiently use graphs, read the labels, and determine and critically think through some information. So the best way to do that is to practice with our graphing and continue to move in that direction. So when you look at the title that I have up here on the screen, it says constant speed versus average speed. When you look at those words, what is it that makes a difference here? If you think about the word constant, when we say constant, what is that talking about? Something that's not changing. How is that probably going to be different than average speed? So we're going to take a look at that concept today first. And constant speed occurs when the speed an object travels at does not change. And this might be maybe you are going down the freeway and you are traveling at 70 miles per hour and you have a constant speed. So it's something that is staying constant, again, not changing. However, how is that different from the average speed? If you think of the average speed, let's say I wanted to take a trip to Rochester. Would I have a constant speed the whole entire trip to Rochester? And the answer is I better not be, unless I want to get pulled over by a police officer, right? So let's say I'm leaving from Adams. I'm going to go ahead and get to the highway north of Adams, and I'm going to cruise along, and I'm going to be going 55 miles per hour, and I get to Elkton. What happens in Elkton? Well, you better slow down, or you run the risk of getting a ticket. Then you pass through Elkton, then you get to Dexter, and then you get on the interstate and you're going 70 miles per hour. So your speed is definitely not constant. It is changing at all times in that case. And so what if I wanted to know the average speed that I had while I am traveling on that trip? Well, if I wanted to know the average speed, I have a way to calculate that, and that is the total distance divided by the total time. And yes, this is spelled incorrectly for those of you they're keeping track. All right, so average speed is the total distance divided by the total time. These two concepts not too difficult to understand. So now let's go ahead and put that in the graphing context. You should have a little graph piece of paper I will upload for you that you can take a look at, or you can just go ahead and look at the screen. But what is it that we have on the left side of the screen? It is simply distance in kilometers, and we have time in hours, so we know that time is in control. And this cyclist has started out at position 0 and has gone ahead and traveled 70 kilometers. Well, if I wanted to know what the average speed is, I would take the total distance, which is the slope of this line. Remember, slope is equal to rise over run. And so in this case, the rise going in this direction is 70 kilometers. And if we take a look at the time, how much time has elapsed, that is the run. In this case, we've got 7 hours. And so if you look at the speed over the course of this graph, we end up with 10 kilometers per hour. And I'm writing this with my mouse, and so that's why it's kind of goofy. But this is 10 kilometers per hour. Now, does this graph appear that I am going the same speed the whole entire time? It certainly does, because this slope is constant. So again, the slope, if we take a look, slope rise over run for a distance time graph is going to give us the speed. Now, let's go ahead and take a look at this graph over here. We have some different slopes taking place. And so let's go ahead and analyze this and see what is taking place. If we look at segment A, now again, we've got a distance graph in meters, a time graph in seconds this time. But if we look at portion A, does that have a constant slope? And so the answer is yes. And so what that tells us is that for segment line A on this graph, we absolutely have a constant speed. And so our speed for line segment A, we have to look at the rise over run. And our rise in this case is 40 meters. And our run is 2 seconds. And so if we look at our movement there, we've got 20 meters per second. So in the first 2 seconds, this roller coaster is actually moving 20 meters per every 1 second. Let's analyze segment B. If we take a look at B, what is the rise in B? Well, if you take a look and go over to the edge here, we are staying right at 40 meters. So over the course of time, is there any change in our Y direction? The answer is no. So we've got 0 meters per second. And we've got 1 second because we've gone from 2 seconds to 3 seconds. And so we've got 1 second. And therefore, what is our constant speed at line in segment A? It says 0 meters per second, which also means that we are at rest. If we take a look at line segment C, now what do we see with the line segment C? Is that a steeper slope or is A a steeper slope? And we can see that A is not quite as steep as C, so that's probably going to indicate to us that the roller coaster is going much faster. And we can see from this point that it is a constant slope. And so let's go ahead and do that one in a different color here. Let's put purple. And so we're starting at time 3 seconds and going to time 4 seconds. So what is our rise from this point on the graph to this point? And that looks to be 40 meters. If I look at the run from this point to this point, there is 1 second of time that has elapsed. And so if we go ahead and calculate the slope on line segment C, we get 40 meters per second, and this number is definitely larger than the 20. And so what that's telling us is the steeper the slope, the faster the speed on a distance time graph. And then if we went ahead and calculated D, I'm guessing that we are going to see a change of 40 meters in 2 seconds, and so that is going to be back down to the 20 meters per second. So make sure that you take the quiz, the online quiz, asking about constant speed versus average speed, and then we will practice some graphing in class based on how you did.